Jai Hind. Today our topic of discussion is relations. It is one topic of first unit of discrete mathematics subject KCA 104. In this particular topic, we'll talk about what relations are, definition of relation, different properties of relation, and equivalence of relations. So let us start with our topic of relations. So when we have to show some relationship between two sets, then we use this set of ordered pairs. When we talk about ordered pairs, that can be represented with the cross product A cross B. In this, we will have all the pairs in which the first element will be from set A, that is the first element, and the second element will be from second set B. So what is A cross B? A cross B is set of ordered pairs such that it contains AB, where A belongs to set A and B belongs to set B. So this is our Cartesian product. When we use sets of ordered pairs, these are called binary relation. Let A and B be two sets. A binary relation from A to B is subset of A cross B. A cross B is our Cartesian product. It will contain all the ordered pairs such that first element is from first set and second element is from second set. So let me take an example. If my set A is containing two elements 1 and 2 and my set B is containing two elements, that is 3 and 4. So what A cross B will contain? It will contain all the ordered pairs where first element is from first set. Our first set is having contents 1 and 2. So first element will be from A. So let me take it 1, and second from second. So I can have these two possibilities. One can be taken with 3 and 4. Same way, another element in set A is 2. So I can take elements 2, 3 and 2, 4. So I am having here all the possible ordered pairs such that first element of the ordered pair is from set A and the second element of the ordered pair is from set 2. So when I talk about this is Cartesian product, what is the relation? So what is a relation? A relation is from A to B, which is subset of A cross B. For example, if I say the subset in which the first element divides the second element. So if I take this particular type of condition, so I can see from here that 1, 3, 1 divides 2. So I can take it 1, 3. In second also 1 divides 4. So I will take 1, 4 also. 2 doesn't divide 3. So in the divisibility operation, this particular pair will not be included. If I see the fourth one, 2 divides 4. So it is also part. So I am having a subset such that the first element divides the second element. So this is one relation. A binary relation from A to B is a set R of ordered pairs where the first element of each ordered pair comes from A and the second element comes from B. We use the notation ARB to denote that A, B belongs to R. So this notation, when I am talking about that 1 divides 3, I can represent this as 1 is related to 3. 1 is related to 4. So that is the way to represent a relation. So this is our relation definition. When we have the relation from set to itself, then we will have it A cross A, from A to A. So a relation on a set A is a relation from A to A. So in this case, what it will be? It will be the subset of A cross A. So here let me take A as one set 1, 2, 3, and let me take a relation R in which again I am taking divisibility. So if I take this divisibility, so my relation will be this from set of elements of A to set of elements of A itself. So 1 divides 2 as well as 3 as well as itself. So it will contain 1 1, 1 2, 1 3. Now 2 doesn't divide 1 and doesn't divide 3. Same way 3 doesn't divide others. So this is our relation here. In this, the relation on a set A is from A to A itself. So we are taking it as subset of A cross A. So this is our relation definition. Now in this particular video, we will talk about detailed in the detailed manner the properties of relation. So I am taking all the properties one by one. The first property is reflexivity. A relation R on a set A is called reflexive if A is related to A, or we can say A comma A belongs to R. For every element A belongs to A. So let us understand this property with help of an example. So I am taking firstly the example of subset. So let me take my set is set of sets and my relation is subset. What is subset? Subset A is subset of B when all the elements of A are present in B also. So now we are talking about reflexivity. So if I consider any set, we know that every set is subset of itself. So it is a reflexive relation. What is reflexive relation? When an element of a set is related to itself. We can write it as ARA. When A is related to itself for all A belonging to the set A, then we call it reflexive. Let us take another example. Let me take the example of divisibility again. Divisibility. Let me take the relation is divides. I am taking the relation as divides. So if I take all the integers and my set A is Z. So we know that every integer divides itself. As every integer divides itself for all A belonging to Z. So what does it mean? It means it is reflexive in nature. So mainly we need to check that A is related to A for all the possible elements or not. If it exists, then the relation is reflexive relation. Second is symmetric. What is the symmetric property? A relation R on a set A is called symmetric if B A belongs to R whenever AB belongs to R. What does it mean? It means if A is related to B, then B must also relate to A for all AB belonging to the set. If we take any two elements from the set such that A is related to B, if reverse property also holds, then it is a symmetric relation. So again, let us take an example. Let me take the example of equal operation. The relation is equal. So when we are having equal to relation, then if I am having a number, an element, A is equal to B, then definitely B is also equal to A. If A is equal to B, then definitely B is also equal to A for all AB belonging to the integers. So it is a symmetric relation. What is symmetric relation? If A is related to B, then B is also related to A for all AB belonging to the set A. Now let us take another example where we can check how the how the relation can be symmetric or not. So let me take another example in which it will not fulfill the condition. So my second example is related to subset. The relation is subset, set inclusion. Now let me say if A is subset of B, then it's not necessary that B will always be subset of A. It is not necessary that B will be subset of A. So this is not a symmetric relation. It is not a symmetric relation. Now let us try to understand with another example. Let me say the relation is brother relation. So if A is brother of B, then brother of B, then if both are male, let me say it is a group of boys, the set is set of boys, and A is brother of B, then B will also be brother of A. Brother of A. So this is a symmetric relation. If we do not take the set of boys only, it is set of boys or girls, and when we say that A is brother of B, in that case the reverse may be true or may not be true, because we are taking girls as well as boys. So maybe the reverse relation is of sister. So in that case it will not be a symmetric relation. And if we take the set of boys, then this is a symmetric relation. So we have studied reflexive. In reflexive, A is related to itself, and in symmetric, A is related to B means B is related to A. Next property of relations is antisymmetric relation. What is antisymmetric? A relation R on a set A such that for all AB belonging to A, if A is related to B and B is related to A, then it means both are same. A relation R on a set A such that for all AB belonging to A, if AB belongs to R and BA belongs to R, then A is equal to B is called antisymmetric. What does it mean? It means both side condition if exists only in one case. What are both side condition? Means A is related to B and B is related to A is related to B and B is related to A. In that case, A is always equal to B. It means A is equal to B for all AB belonging to A. So now let us understand the property of antisymmetry. Again, let me take the example of subset. Subset example. What is subset example? That is inclusion. So if I say that I am having set of sets, and for two sets A is subset of B and B is subset of A, then we can understand, we can see from here that all the elements of A are in B and all the elements of B are in A. This is possible only in one case, when A is same as B. So what does it mean? It means this relation is antisymmetric. This is antisymmetric relation. Same way, let us understand with another example. If I take divisibility over positive integers, divisibility over positive integer. So A divides B and B divides A, we can see that a number A divides B and it is also divisible by A only in one case, when A is equal to B, for all AB belonging to set of positive integers. Set of positive integers. So this is the property of antisymmetric. Now next one is transitive. A relation R on a set A is called transitive if whenever AB belongs to R and BC belongs to R, then AC also belongs to R for all ABC belonging to A. What does it mean? It means if A is related to B and if A is related to B and B is related to C, then A is also related to C for all A, B, C belonging to E. That is transitive, means A is related to B, B further related to C, then A will also be related to C. This is called transitive property. So let us take an example. Let me take initially equal relation on integers. Equal relation on integers. So when A is equal to B and B is equal to C in integers, then definitely A is equal to C for all ABC belonging to the set, that is ZA here in this particular case. So this is transitive relation. We can understand with another example. Now our example is divisibility. Divisibility on set of integers. If an integer A divides another integer B and B divides another integer C, then definitely A will divide C for all ABC belonging to the set A. So this is a transitive relation. This is transitive relation. So we have discussed 4 properties. The properties are reflexive relation, symmetric relation, antisymmetric relation and transitive relation. Now we will understand a very important definition, a very important type of equivalence relation. When a relation on a set A is called, equivalence relation if it is reflexive, symmetric as well as transitive. If all the properties are holding, then we call the relation as equivalence relation. Two elements A and B that are related by an equivalence relation are called equivalent. The notation is this: A is equivalent to B. It is used to denote that A and B are equivalent elements with respect to a particular equivalence relation. So this is the definition of equivalence relation. Firstly, we started with the relation, then we studied properties of properties of different types of properties of relation, then we studied the equivalence relation definition. Now let us check a given relation is equivalence relation or not. So now what we are having here, let R be the relation on the set of real numbers. So the relation now is given on real numbers such that A is related to B if and only if A minus B is an integer. So when we are having real numbers and their difference is an integer, then the relation exists. So now let us check, is R an equivalence relation? So to check a relation is equivalence, firstly we need to check the relation is reflexive or not. So we have just studied that a relation is reflexive if A related to A for all A belonging to the set. Now our set is set of real numbers. So as it is set of real numbers, so we are using here the term R. R means the set of real numbers. So A related to A for all A belonging to R. This we need to check. Now what is our relation? Our relation is A minus B. So now let us check what is A minus B. Is it an integer or not? So if I take two real numbers and I subtract one real number from itself, so what we will get? We will get 0. And 0 we know that it is an integer. So as we are getting A minus A 0, it means the relation exists, because the relation exists, A or B exists if A minus B is an integer. So here I have got 0. So what is the point? Point is that the relation is reflexive, because when I am subtracting A from A, I am getting integer in answer. Now second, what is the second condition to be checked? The relation is symmetric relation or not. So this is our second property that we are going to check. What symmetric property says? It says that if A is related to B, then B must relate to A for all AB belonging to the set. What is set here? That is set of real numbers. That is set of real numbers. This R I am using for relation and this I am using for set of real numbers. So when I see that A is related to B, it means what is given to me, that the relation between A and B. So when we are having a relation between A and B, it means A minus B is an integer. Okay, so let us denote it by M. So what is given to us? That M is an integer. This is given to us, that A minus B is M. Now we will check what is the reverse relation, that is also giving us integer or not. So if I take reverse of this, how can we get that? We can get that B is related to A if B minus A is an integer. So we are checking that B minus A is an integer or not. So when I am taking B minus A, I can write it as A minus of A minus B. Minus I have taken common. So I am writing it minus of A minus B. So my A minus B is given an integer which is M. So minus M. So as we know, when M is integer, minus M is also integer. For example, when 2 is integer, minus 2 is also integer. When minus 2 integer, then minus of minus 2, that is 2, is also integer. So from here we have shown that the difference between B minus A is integer when it is given that A minus B is also an integer. So the symmetric property is also true, just like our reflexive property. So in this particular case, we are finding that it is a symmetric relation. Now the third property that we need to check is transitivity. If the relation is transitive relation or not. So let me take the definition first and relate the relation. So what is the transitive relation? If in the relation A is related to B, if A is related to B and B is related to C, then A is related to C or not for all ABC belonging to set. Here our set is set of real numbers, A, B, C, which is set of real numbers. So if now I consider these relationships, it means A related to B. What does it mean? A related to B means A minus B is an integer. It belongs to Z. Same way, B is related to C. B related to C, what does it mean? It means B minus C is also an integer. b minus c is also an integer. So if I add up the two statements, what are my two statements? First one and second one. From here I am getting a minus b is equal to m. Here I am getting b minus c is equal to n. So when I add up these left hand side and accordingly right hand sides, so what I am getting from these two statements, a minus b plus b minus c is equal to m plus n. So what I am getting from here, b got cancelled. So what I got finally, a minus c is equal to m plus n. Now we know m belongs to integer as well as n belongs to integer. So from integer arithmetic we know that the addition of two integers is always an integer. So what I am getting from here, a minus c is m plus n. So what I am getting from here, m plus n is also an integer. So the transitive property also proved to be true. Okay, so this is an equivalence relation. So what we have proved here, we have taken an example of relation and then we checked the relation is reflexive or not, the relation is symmetric or not, and the relation is transitive or not. Because we found all the properties true, so we can say that the relation is an equivalence relation. So this is our information about definition and example of equivalence relation. So in this particular video we have talked about relations, types of relation and what is an equivalence relation. We have done examples accordingly. Thank you. Jai.